Hi everybody, welcome back. We're still stuck at the milling machine, and today we're going to do some actual machining. At this stage you can see there is no cutter, so we have to select the correct cutter for our specific milling operation. This is a replaceable tip surface cutter, sometimes also referred to as a face cutter. This one just got 3 tips, and as the diameter increases, it will have more tips. The tips are made out of tungsten carbide, and they are replaceable. When they break or they get blunt, unfortunately they cannot be resharpened. It's got 3 sides, so if one side gets blunt or broken, you can just move to the other side. So that is the replaceable tip, surface or face cutter. We do also get our high-speed steel cutters. We get the slot drill, and now with this one, you can see that the cutting edges are going all the way past the center of the cutter. So with this one, it's possible not only to do surface cutting, but we can actually machine down just like you would use a drill bit. This one, on the other hand, you can see it got 4. But it doesn't go all the way to the center. So with this one, we can only cut slots, but we can't machine down because it will not be able to remove the material. Yes, if there's already an existing hole, you'll be able to use this one. Now, fitting the actual cutter. What we're going to do today, we're going to use the expandable sleeve. You can see it's the split sleeve, and because it's split, once it's pulled in here, it will actually squeeze down onto the cutter, clamping it very tightly. And they come in different sizes. So this is a 12 millimeter, and the cutter is a 12 millimeter. So you'll have to use a 12 millimeter cutter on a 12 millimeter on this side. Just be careful when you are using a cutter. It's very sharp, so use a rag, and you're going to turn it till it's about in that position there. So the collet is going to go in here, in there, and we'll use the special spanner to tighten it. As we tighten it, those splits will close and squeeze on the cutter to make sure the cutter is nice and tight. Now the cutter has to go into my spindle. Once again, your hands free from the cutter, and I normally just use a rag to make sure I don't injure myself. This here is my draw bolt. Now you can see with my draw bolt that it will go from the top and it will tighten onto your cutting tool holder. And what will happen, it will pull it in to the spindle once you tighten it. So that's exactly what I'm going to do now. One thing I didn't mention, always make sure when you're changing cutting tools that your machine is switched off. at the wall socket. Simple reason for that. Remember, your hands are in contact with the cutting tool. If you start up the machine at any time by accident and your hands are in contact with your cutting tool, you're going to be severely injured and maybe get disciplined as well for your stupidity. So make sure that your machine is switched off at the main circuit breaker. Next, you're going to tighten your draw bolt. Now, this is very important. Never use the ring. Remember I said use the ring before? Now I'm going to tell you don't use the ring. For the simple reason, I have seen people forget it in position that I have tightened it, and they leave it like that. They start up the machine, this comes flying off, and unfortunately, if somebody's standing in the way of the spanner, they're going to be injured. So always use the flat side for the simple reason is that you won't forget it there. It will come when your hand goes. Once again, pull it towards yourself. Don't push it. Make sure you got the correct size. Don't use a shifting spanner. Make sure you got a right size. If it's a 19 spanner, don't use a 20. 18 is not going to fit. A 20 will fit, but you're going to damage your draw bolt. In this case, it's a size 19, so make sure you use a 19. Hold your spindle and tighten it. You don't have to tighten it too hard. In other words, you don't need to put excessive force on it. For the simple reason, when your cutter is running, it will tighten it self-automatically. Now, while I'm here fitting, what are we going to do when we are removing the cutter? It's the same process, only in reverse, but it's not as simple as that. What I do find a lot of students do is they'll do this, they'll loosen it, loosen the draw bolt completely, and you'll find that spindle won't come out. Then they'll take a hammer and they'll hit it, and then the spindle will come out. But the problem is there, if you do that, you're going to damage the thread. The draw bolt thread, remember the thread is not inside like this, like that. It's actually just on top of it. And when you hit it now with a hammer, you're not only going to damage your draw bolt thread, you're also going to damage your thread on your collet. So very important that when you're going to remove it, always make sure that there is thread. There is thread. And remember to put your hand underneath so that when it comes out, it doesn't drop, fall on the cutter, and damage your cutter. So I'm just going to put it back. Right, my cutter is nice and tight. And now I just want to take a simple cut on a piece of metal. It's not a specific workpiece, it's just to demonstrate how we cut. It's a piece of mild steel. Now what you'll normally find with most steels, it got this black layer on the outside. And that is known as scale. That happens during the manufacturing process of it. When they do the hot rolling, it leaves this black scale on the outside, and that's normally quite hard. So when you're ever going to take your first cut, don't take a big cut, don't use very fast speeds and feeds, because that black scale might damage your cutting tool. Now the cutting tool we're using here at the moment is a 12mm slot drill, and it's made from high-speed steel. So if I break this one, unfortunately, I'll have to replace it. Very few people know how to sharpen it. I'm going to use my parallel strips. And the two parallel strips are the same size. I'll use my soft hammer to hit down on my workpiece to ensure it's set nice and flat. And while I'm hitting it, I'm actually tightening it. That is just to make sure it's set nice and flat on my workpiece. I'm just going to take a nice small surface cut. So I'm going to bring my cutter closer to my workpiece. My safety glasses. Make sure that my cutter turns in the correct direction. In this case, it's clockwise. If you by accident put it in the wrong direction, don't just switch it over. Wait till the machine comes to a complete stop. Otherwise, you're going to break the gearbox. It's like driving a car in fourth gear and then putting it into reverse. It's not going to be so healthy for your gearbox. Same in this case. I'm going to make sure my cutter runs clockwise. I'm going to lift my table. Until it just touches the workpiece. And you can see I'm using two hands because I've got better control. Take a slightly bigger cut. I'm using my hand feed and not automatic feed. And if I do that, I must make sure that I go a nice, smooth, slow, equal turn. Not too fast, not too slow. I don't jerk. I have a continuously movement. I can obviously use my automatic feed, but I'll have to slow it right down. Now just a reminder about your cutting speed and your cutting feed. It depends on a few things. One is the material. The harder the material, the slower your rotational frequency of your cutter and the slower your feed. The softer the material, obviously you can go faster. The next one is the actual diameter of your cutting tool. The larger your cutter, slower your speed. The smaller your cutter, faster your speed. And then the last one, the actual machining operation. Are you cutting a gear? Are you cutting a T-slot? Are you grooving? What are you doing? So that will influence your cutting speed. And remember, there is a formula and a calculation where V is equal to pi dn, where V is your speed, pi, d is the diameter of the cutter, n is the rotational frequency of your cut, in other words, the RPM. And there, I've done my first cut. Disengage my automatic feed. Remember, everything is sharp, so if you want it clean, use a paintbrush. And you can take your next cut. So what I'm going to do is I'm going to complete that cut, and I'm going to measure it and then turn around to get an exact dimension for them. All right, so if I want to take a surface cut there, I'll have to run it up and down, up and down. It's going to be quite time consuming. So this cutter is obviously not suitable, although it can do it, of cleaning up this whole side with one cut. So for that, I'm obviously going to use a bigger cutter. So this is the one I'm going to use. Make sure I switch my machine off. My 19 spanner. Remove my cutter out of my collet. The cutter normally comes in a little protective box. And replace everything in its box. So we're not going to look for everything again next time. Now, I'm supposed to slow down the speed, but I'm going to use the same speed. I think the speed will be fine. We'll see now when we cut. But to change the speed on this specific milling machine is very cumbersome. You have to remove the guards here. You have to slacken off the tension on the motor. And then according to the different pulley sizes, we can achieve speeds from 220 right up to 1,600 RPM by utilizing the belts. Unfortunately, that's quite a pain. A better quality milling machine will be fitted with a geared head. With the geared head, what a pleasure, because it's like a gearbox in a car. You'll have a few levers, and all you have to do is to switch the levers to the correct position, and you'll have your desired speed. Right, so with this cutter, I will be able to take one cut and remove all the material at once. Safety glasses. I'm lifting the knee. I'm going to use my automatic feet. By utilizing this cutter, I can cut in one time the whole surface. Now here's a quick question, why are we machining here? If we have to machine a very large area, for example, say this table here, or if you are familiar with car engines, the head or the block, they're referred to as a scheming. You also will use a milling machine, but in such a case, running up and down with this size cutter is going to be very time consuming. Also, it's going to leave marks when you fit your gasket that can cause water to leak. So in that case, we make use of a process called fly cutting. I'm pretty sure if you use some of the platforms available on the internet, just say fly cutting on a milling machine, and you'll get some excellent videos that will demonstrate fly cutting. So fly cutting is a process where we can cover a very large area with one single cut without using an expensive cutter like this one. It's nearly there. If I wanted, I could have set up my table stops, and in that process the machine will stop automatically when it reaches its limit. Drop my table. You can see that I didn't use a cutting fluid, and for the simple reason I'm using tungsten carbide bits, and I'm using mild steel. So mild steel is not all that hard, so I'll get away, and I haven't taken a very big cut. And there you can see clearly one nice smooth surface. So if I want to get this piece of material to an exact dimension, I already got my one reference. Let's say, for example, I want, currently this piece of material is 11.5. Let's say I want to get it exactly to 10 millimeter. I'm going to take another smooth cut on this side, not too much. Measure using the dial on my knee. I'm going to lift it the correct amount and get it exactly to be 10 millimeter. Right, that we can do in the next lesson. So let's quickly recap. What have we done today? We've learned how to clamp our workpiece using our parallel strips. We've learned how to fit a cutter using a collet, a split collet, or a cutter directly into the spindle, the safety around it. We've learned how to take a surface cut with a 12 millimeter cutter, which shown on a large surface is going to take you some time, or using a large diameter cutter. One cut and our surface is clean. We also learned about speeds and feeds. Right, your practical assessment on a milling machine, your ISAT. You'll see that one of the components that you have to manufacture, you have to make a small hammer, and the hammerhead itself have to be machined on the milling machine. So it's vitally important that you understand how to fit your cutters, how to select your correct speeds and feeds, how to measure. So go and brush up on your measuring equipment, vernier, micrometer. You also have to do some drilling here, because this machine can be used for drilling as well, and threading. So for that, you are going to require to machine that component on this machine. As far as the exam is concerned, what is going to be expected from you? It's going to be expected from you to know the safety. And the safety, once again, is environmental safety, personal safety, safety before you're going to operate, safety while you're going to operate. They're going to ask that. They're going to ask you the components on the milling machine. They might give you a diagram and say, you must mention where's the head, where's the base, where's the column. You must know that. You'll find in your textbook there's a good sketch about it. You must know the different types of milling machines. You need to know the different machining operations that can be performed on a milling machine. You must know the different cutters that you get on a milling machine. Make sure that you are ready when you have to perform your ISAT. Once again, at the bottom of your screen, you'll see there's some information, contact information. If you've got any questions, feel free to contact us.